There. All right, welcome to our, what I'm considering our final normal homeschool connection night for this 2014-2015 school year, because the one next week is going to be about Virginia Studies, which is our one and only one about Virginia Studies. And then 2 weeks from tonight is the one that I'm really looking forward to. That's going to be the students versus parents one. So tonight's topics goals are going to be a mixed review of, you guys pretty much chose the topics, and I kind of structured on that. And then we'll be previewing the SOL. We'll be previewing on the math SOL and the reading SOL, because there's not another reading homeschool connection night before the reading SOL. So I'll preview both of those with you. We'll do the preview of the Virginia Studies SOL at the Virginia Studies night. So we'll be going over both SOLs. Again, workshop is here to guide you in helping your student prepare for math tests and preparing them for the future tests, and really the SOL. Now that we are, yesterday was 2 weeks out from our first SOL, the Virginia Studies one. For math, we were about two and a half, three and a half weeks out. So this night is going to be very crucial. I'm very happy and thankful that you're all here to talk and see what are going to help for the SOL. Feel free to take notes. The packet tonight is a little more brief than the normal packet, because, which leads to my third point. This night is going to be very different than past nights. Past nights have been a lot of kind of me talking, explaining the theory, explaining how test questions are going to be worded on tests, how students, general common mistakes that they do, all that kind of stuff. All of that is available on my website and on my YouTube channel, so you can go back and look for those stuff. The goal of tonight is really for me to model more examples for you, moving at a little bit of a slower pace, and then also that after I model an example, it'll be your turn to actually do an example. And I'll even be calling on volunteers to come up and actually solve it on the board. So you'll see that tonight, rather than really talking about the theory behind it and how test questions can be worded, it's going to be more the mechanics behind it, which we had touched on throughout the whole nights, but this night is going to be more on that. So get ready, because everybody's going to be actually doing a lot of demonstrating tonight, and as well as me. So when you filled out the survey, I had you pick 5 topics. After after I looked at that, I analyzed it, and the top 5 most requested topics were fractions, decimals, multiplication, long division, and elapsed time. And truth be told, I probably didn't even need to poll you, because I knew those were going to be what came up. So I'm glad that you picked those ones, because those are the ones that I was kind of planning on reviewing anyhow. The other skills that people had voted for included geometry, measurement, whole numbers, and probability, in addition to other skills. While those are skills that are going to be very important on the SOL, it was kind of hard to justify doing a whole nother night on those. But you can always, those have been covered in past homeschool connection nights. And so you can always go back and revisit those. I really encourage you to look back at the presentations on my website and the YouTube videos. Those together are going to be really helpful. I really encourage you to look at those with your student. It's great to look at them by yourself, but also it's going to be really important to look at them with your student. So the first thing that we're going to talk to about tonight is fractions. They're going to have a whole lot of things to do with fractions on the SOL. They're going to have to identify pictures, which pretty much is a strong point. Fractions, identifying pictures, they started that in like 2nd grade. They're just, rather than saying like 1 out of 4, now they're saying 1/4. Number line, which they did do really well on that, and I'll show you exactly how that works out. Division statement, by and large, they do pretty well with that. LCM, GCF. While they are good with that, they switch which one they're supposed to do. Sometimes they'll do the GCF thing for LCM and vice versa. So we'll talk about that. Equivalent fractions, we will talk about that on model example. Adding and subtracting fractions, comparing and ordering fractions, reducing fractions, and the decimal equivalent. The basis of pretty much everything with fractions is going to rely on the least common multiple, the LCM, but there are a lot of shortcuts that I'll kind of talk you through. But equivalent fractions, adding and subtracting fractions, those are going, there's really no way around it. They do need to know how to do LCM. Comparing and ordering, there is a way to do that with either calculator or the butterfly method, which we'll go through. Reducing fractions, they really do need to know the greatest common factor, or at least common factors. And decimal equivalents, they can kind of use a calculator for that, but it's also a lot more helpful if they just know it off the top of their head. So this is going to bring me to the first example. So the first 2 things that I'll show you is fractions on a number line, and then fractions as a division statement. And like I said, the video is recording all of this, so if I'm moving a little fast now, feel free to revisit the video afterwards, and I'll really talk through every step. So fractions on a number line, what they're going to be presented with is going to look something like this. They would also have either a 0 and a 1 here, or like a 1 and a 2, but 2 whole numbers at the end of each line. What I tell them to do is to count each little line first. So they just go 1, 2, 3, 4, 5, 6, 7, 8. They do need to include the last line because it'll make sense when I get to the denominators. They don't necessarily need to include the first line. Some of them do and just put a little 0 there. Now they see that the last number they came to is an 8. So that means that each little line represents one of 8 parts of the line. So all they do is they go back and they put in their denominators. So everything is out of 8. Now they've essentially labeled every single line as a fraction. Then the last step they have to do is just see where the star, the point, whatever it happens to be, is, and it's right there, and it's 5/8. As long as they remember to number every single line, including the last one, the biggest mistake that they're going to make is not including that last one because there's going to be a whole number there. It's pretty straightforward. Like I said, I cannot stress enough that last, generally speaking, they don't mix that up because when we're playing a game that I like to call Find Mr. B's Mistake, is I will not count that last one. And you should see how quickly they got up in arms. No, Mr. B, you need to do that last one. So this is going to be very helpful. Not only is this skill going to be helpful for fractions, but also probability, because one of the things on probability is representing probability on a number line as a fraction. So it's basically just the continuation of this. The other thing I'm talking that I just wanted to touch on is fraction as a division statement. Fraction basically just represents a division statement, and the way that I tell them to do that is just read it top to bottom. So they just read 3, the division or the fraction bar works as a division sign, and then 5. So it would just literally be 3 divided by 5. And they don't even have to take it to the next level where they would actually divide that. That's a 5th grade skill where they will end up dividing that. But all that they will see on the SOL is it will say what division statement would that fraction be. So all they have to do is read top to bottom, or the vice versa of it. It might say, how would you represent 3/5 as a fraction? And they just have to do 3 fraction bar 5. So that's pretty much 2 overall basic skills. We didn't really delve into the fraction as a picture because that's a pretty much standard thing like this. It gives them 4 things. They're pretty good at figuring out that is 1/4. These are the 2 newer skills that they're going to have in 4th grade. They've had the past skills of either the pictures, or they'll have like 5 kids, 2 of them are girls, and they have to say 2/5 are girls. But these are the 2 newer skills. By and large, they did not make too many mistakes with this. The only, like I said, the mistake up here would be not counting the last whole number. Mistake down here would be flipping it and doing 5 divided by 3. Before I move on to the next thing, do we have any questions? And don't hesitate to ask questions. All right. So one thing that they will see is these are called area models of fractions. So, and the question will say which are equivalent. Now this could happen in a number of ways. It could give it like this, and it could be one of those technology enhanced items that I keep talking about, where they can pick more than one answer. Or it could be, it might say like model 1 and model 2, model 1 and model 3. It could be a multiple choice answer. Either way, it's going to be solved the same way. The first step what the students need to do is simply go and figure out what each fraction is. So this one has 1, 2, 3, 4. So the bottom denominator is 8, and there are 5 or 4 shaded in, so that's 4/8. They do the same thing over here. There are 9 there. 3/9. They do the same thing over here. 3/6. And then they do the same thing over here. That is 6/10. So that's the first step that they need to do. Pretty much anytime they see some sort of picture of a fraction, they should probably identify it in numbers. That's going to make everything easier. So equivalent is just a fancy word that means equal or the same. They just need to, and so the way that they could do this in a number of ways. I'm going to show you the shortcut way that I've advised them to do because they do have a solid background in making equivalent fractions. They can do the long way where they find the LCM and then convert them all, but there's a much simpler way to do this. So the simpler way to do this is they pick one fraction and another one. So they do 4 8s, and they put it right next to 3 9s. Then they do what you might know as a cross multiply. We call it the butterfly method because it kind of makes a nice little butterfly down. They circle crossing, going from bottom to top, and they see that that would multiply to make 24. They do the same thing over here, going from bottom to top, that would make 36. They see 36 and 24 do not match, so they know that this one and this one are not equivalent. So then they would, is it okay to erase this? They do the same process with, they would use, again, they pick the first one and do the second one. So 4 8s, put next to 3 6. Circle it. 3 times 8, or 8 times 3 is 24. 4 times 6 is also 24. So they see they came up with 2 24s, which means that this one is definitely equivalent with that one. The next thing they would have to do, because one mistake that they might make is see that, okay, those two are equivalent, I'm going to stop and move on. Especially if it doesn't say how many they want to choose, it's important for them to check all of them. So they would continue the same process with 4 8s and 6 tenths, circle 48. That's a weird 8. Circle and 40, they're not equivalent. So they have determined at that point that these two are equivalent, but what they would have to do, I would advise them to do, is then go back. They don't need to check those two, but they do need to check these two, and then by process of elimination, all they would have to do at the end is check these two. So the thing might be that they don't want to check all of them because that was 1, 2, 3, 4, 5, 6. That would be 6 different butterflies they'd have to make. They have a whole butterfly garden by the end of it. But it is important that they could. The other thing that they could do, which is probably going to take equal amount of time, is find the LCM, which we'll go into, of all the bottom denominators, which that's going to take a long time, especially to find the LCM of 8, 6, 9, and 10. That is a big number that I can't figure out off the top of my head. Another way I just realized as I'm talking that they could do this, that would probably save them time, is to just use a calculator and turn them all into decimals. Because this is going to be part of, to the best of my knowledge, don't quote me on this, I have to see the thing at the end that talks about what sections they can use the calculator on. Yeah, they should be able to use a calculator on this section, but if they just took these and did 4 divided by 8, they get 0.5, 3 divided by 9, they get 0.3, 3 repeating, 9 or 6, whatever number that is, 3 divided by 6, they get 0.5, and 6 divided by 10, they get 0.6. So then that would be a really quick and easy way for them to just look like what the decimals match. And I will go over that with them in class when we start, really delving into the review of this kind of stuff. So a couple different ways they could attack this problem. They have a whole lot of ways to do it. It's just kind of finding what works best for them. At this point, I would say what works best for most of them would be the way in which I just demonstrated with the butterfly. As they get more comfortable with calculators, which we don't use a whole lot during 4th grade because it's important for me to know that they can do the skill before they can do it on the calculator, they might become more comfortable with that way. But you need to go with what's best for your own personal student. Questions before I move on? All right. This is going to be talking about least common multiple and greatest common factor. Like I said, their big problem necessarily isn't how to do LCM or GCF. It's when they are supposed to do which one. Hopefully, or they mix up the processes. Like sometimes it asks the question, what is the LCM of 2, 3, and 4? And they might do something with 2, 3, and 4, but they might do the birthday cake method for the GCF. I try to advise them that if it's going to ask for your greatest common factor, it's generally going to be a larger number. If it asks for LCM, it's going to be a smaller number. So really making sure that they understand which process goes with which is going to be important. So for LCM, we'll talk about the first one first. For LCM, they simply just list all the multiples. Originally, I had them list all the multiples from like 2 times 1 to 2 times 12. What I tell them now, especially if it's just asking for least common multiple, do the first 5, move on to the next number, do the first 5, move on to the next number. By that point, you might have a match. If not, they have to go back and do a couple more. I just try to save them time at this point rather than do it up. So all they do, pretty much they would count by 2. So it would be 2, 4, 6, 8, 10, 12. I did the first 6 there. I'm going to move on. So then they'd go to 3, 3, 6, 9, 12, 15, 18. I'll just go to the 6 there. They go here. 4, 8, 12, 16, 20, 24. Then what they have to do is they go back and they look for a number that matches with all 3. If it gives them 3 numbers, it's important to make sure that they match it with all 3. If it gives them 2 numbers, 2. One thing that might trip them up is picking a number that goes into only 2 of them. Like if I would have extended 2 out all the way, it would eventually get to a 20, and they'd see a 4 down here goes into 20. So it's important, but 3 does not go into 20. So they can't get hung up on the fact that there is a match, but there needs to be a match for all of them. So if we look, 12 would be our LCM, so all of those would have in common. 2, 3, and 4 have a couple other numbers that are in common. They have 24 in common, for example, which would be okay as a common multiple, but it's asking for the least common multiple, the LCM. They need to make sure that they get it to the smallest number that they have in common, which will also then make their life significantly easier when they're trying to reduce the fraction. I'll leave it up to you guys if you want to practice LCM now, and then I'll go back and do GCF, or if you want me to do GCF too, and then we practice both on the next slide together. What's the general feeling? Do you want to do LCM first before I move on, and then come back, or do you want me to do GCF now, and then we'll do both on the next slide?
LCM, it's good.
Okay. All right, so you should have a whiteboard in front of you, and you locate a marker. Make sure some of the bins have Sharpies in them. Make sure you don't grab a Sharpie. Let's do that. All right, so we'll start with the LCM of 5, 6, and 10, because that's relatively easy things to work with. So what's the first step that we should do here?
5. Put a 5.
Put a 5.
And then 5, 10.
6 and a 10.
5, 6.
And then what do we do?
And then common.
Yeah, you just count by 5. So go ahead.
5, 10, 15, 20, 25, 30.
So we did the first 6, and we do the same process for 6.
6, 12, 24,
18.
Oh, 18, sorry.
No problem.
12.
And then for 10s.
That's tough.
It is tough.
20,
And
10, 20.
We'll come back to 30 again.
40.
40.
Or for the. Oh, I was like, wow. All right. And then what do we have in common between all of them? We do have 30 in common on all of them. So that's how you do LCM. As long as they know their multiplication facts between not being able to differentiate the process between GCF and LCM, the other big problem is going to be not knowing their multiplication facts. Cannot stress how important that is to know all their multiplication facts. So let's head on back and do GCF this time. So for GCF, this is a method that I call the birthday cake method, because you kind of build a birthday cake. So for birthday cake, the first thing that they need to know is the magic numbers. Does anybody remember the magic numbers from when we talked about? 0 is not a magic number, but good try. 2 is a magic number. Also known as prime numbers.
Oh.
2, 3, 5, 7, 11, and 13 are going to be, there are infinite number of prime numbers, but that's the ones that they need. So then what they do is they put the number 24 down there, they put 36 over here. And they start building their cake. So which of the prime numbers or the magic numbers can I pull out of 24?
2.
Yes, you can pull 2. How many 2s can you pull out?
12.
12. Is 12 a magic number? No, so you need to build another layer. What number can I pull out of 12?
2.
2 again, which would give me 6. Is 6 a magic number?
No.
No, so you need to build another layer. So then you can pull 2, and 3 doesn't really matter what order. Is 3 a magic number?
Yes.
So that's our candle. Now we just need to count up our candles next. So we have 3 times 2 times 2 times 2 is what's called, for adults, it's called the prime factorization. For the kids, it's called Campbell's mixing. So then we do the same process for 36. Which number can we pull out of 36? 3. How many 3s can we pull out of 36?
12.
What? Is 12 a magic number? No. So now we can pull something else. What can we pull out? 2, 6, and then we're going to 3 times 2 times 3 times 2. Then the last step in this, they go back and they circle what they have in common. So do they have a 1, 3 in common? Yes. Do they have a 2 in common?
Yes.
Do they have a second 2 in common?
Yes.
Do they have a third 2 in common? No. So that's dead to us. Do they have a second 3 in common? No. Tell them that it's dead to them. So then what I tell them at this point is after they've made their circles, they're only worried about 1 cake. Don't be greedy, don't eat 2 cakes. So they're only worried about the 1 cake. So then they have a couple things circled and they have a bunch of multiplication signs in between. So they would do 3 times 2 times 2, which would give you 12. So then the greatest common factor between 12 and 36, 24 and 36. Well, either way, the greatest common factor between 12 and 36 is also 12.
Can we
Some-
have number 1?
What?
Can we have another example?
Yeah, we're gonna work through one together, and I'll help you through. So we're gonna go
Indigestion.
and do it. All right. So let's see who was paying attention. What are the magic numbers?
2, 3, 5, 5, 7, 11, and 13.
Very good. Good job. Some of you. Now we start building our birthday cake. So we need our base layer. So it would be 18 over here
27.
and 27 over there. Build your first layer. So which magic number can I pull out of 18?
2.
Yes, you can pull 2 out. The nice thing about this is you could have pulled a 3 out either. It doesn't matter what number you pull. You're going to eventually pull all the right numbers out. So 2 out of 18 would be
9.
is 9 magic.
No.
We're pull 3. 3. Is 3 magic?
Yes.
Flavor candle. Now we got to count up our icing. So we just take from top to bottom 3 times 3 times.
Is it important to take it from the top to the bottom, or does it?
You can do bottom to top. You're going to get the same numbers no matter what. I just like to go top to bottom because I'm already up there, so it just makes more sense to fall back down.
Matches the base layer. Okay.
What? Yeah, it's kind of like going down the steps. It doesn't matter. Same numbers are there whether you're going up or down. So 27. What can I pull out of 27? 3. And what can I pull? How many 3s can I pull out? 9 magic.
Multiply by 3.
Then we have candles, icing, just simply 3 times 3 times 3. Now we go back and we look for matches. Do they have a 3 in common?
Yes.
Do they have a second 3 in common?
Yes.
Do they have a 2 in common?
No.
Dead to us. Does it have a 3 in common?
No.
Dead to us. At this point, we only worry about one of the cakes because we're not greedy. So we've got 3 and the 3 with multiplication sign in between. Gives 9. So the GCF between 18 and 27 would be 9. Quick and easy way to do it. If your student's really good with film multiplication facts, they can kind of look at the numbers and figure it out. That's how you do LCM and GCM. We're going to move on to the next thing, which I want to say is, yes, adding and subtracting fractions. Which adding and subtracting fractions is kind of the next level to LCM and GCM. First thing that they need to know is what sum means. Because it's not going to present it, generally speaking, as a nice 1/2 plus 2/7. It's going to say find a sum of 1/2 and 2/7. And I will bet you any number in my paycheck, which might not be an enticing bet, that it will say sum, but it will also have the subtraction answer there. So it's important that they know the difference between sum and difference. So the first thing they need to do, obviously, is just set it up horizontally. Some teachers have them do it vertically. I find it's easier to follow along with the changes if they do it horizontally. But teacher preference. Then what they have to do is find the LCM of the denominators, because they know that you can't add denominators that aren't the same. They just don't get along. So they would have to do the LCM of 2 and 7, which 2, will come to 14 eventually. 2, 7, 14, 14 is your LCM. What I have them do from there is then set that as the answer denominator. So they know that their answer eventually at some point is going to end up in 14s. Eventually it might be reduced then too, but at some point it's going to end up in 14s. So I haven't put it up here, so that just helps them remember what they're converting this all to. From here, they need to basically convert these into equivalent fractions, which I've taught them kind of a saying that they should have it ingrained in their mind because we say it all the time. They basically take the first fraction and they say 1/2 times something equals something over 14. I'm looking at that. So then I have them go back in and fill in the blanks. So what times 2 will give you 14?
7.
7. And whatever you do the bottom?
Back to the top.
There it is. Some of you. 1 times 7 is
7.
7. Then you just take that and put it under the 1/2. Because 1/2 and 7/14 are valued the same. They're just different numbers. Then they have to repeat that entire process with the second one. So it's 2/7 times something equals something over 14. They go back and fill in the blanks. What times 7 is going to give you 14?
2.
Whatever you do the bottom.
Back to the top.
2 times 2 is?
4.
Plug it in under the. Just drop down the symbol. I've seen one common mistake, or not really a common mistake, more funny mistake, that they will have no problem with this, no problem with finding the LCM, but they'll drop like a multiplication or addition symbol and drop down a subtraction symbol, and which will give them a completely wrong answer. They might have done the whole process right, and when we're showing our boards to everybody in the group, they have an answer that's like significantly smaller, significantly higher. And I said, well, you did have no good 14, so what did you do wrong? It was an addition subtraction. So just making sure that they bring number at sign is going to be helpful. So then they never tell them that, I tell them that they never, no matter what, ever add the denominators or subtract the denominator. I've told them that even if someone comes up to you and threatens you, you don't add the denominators. So if your child's come home and been like, Mr. B said people are going to come up and threaten me. That's true. But it was to help them with this. So they just bring the denominator straight across. Then they just take the numerators and add those. 7 plus 4 is 11. They just pop that up. The next step would be to check how to reduce it. I'm going to do a whole separate slide on reducing. But so their final answer would be 11/14. We're going to work through one together next, which it'll be the next slide. There.
Pretty sure my son will crush me on this.
Well, we'll find out in 2 weeks. All right. So it says the difference of 2/3 and 1/4. So this is the one that we're going to work through together. So we need to set it up horizontally first. So I got my 2/3 and 1/4. What symbol is going to go in the middle? Subtraction. Why is it subtraction? It says difference. So what's my first step?
5.
Yes, find your least common multiple. 3
and 4.
Yep. You do the LCM thing that we were just doing. 2 slides back. What is the LCM? 12. So what do I do with that 12?
Denominator.
Yep. The answer denominator. Now I go back and I start making equivalent fractions. So say it with me, make me feel like I'm not the only person in the room. So you say 2/3 times something equals something over 12. Thank you. I feel like there's something. What times 3 is going to give you 12?
4.
4. Whatever you do to the bottom.
Got to the top.
2 times 4 is?
8.
Plug it, fill it in just underneath. All right. Should have left yourself. All right, then we go back and we do the same thing. We'll say it.
1/4 times something equals something over 12.
Very good, thank you. What times 4 is going to give me 12?
3.
And whatever you do to the bottom.
You got to the top.
1 times 3 is?
3.
Plug in. Drop down my subtraction symbol. Do we ever subtract or add the denominators?
No.
Never.
No, not even if you're I use all sorts of different things. Ask them sometimes, it'll be interesting. 8 minus 3 is,
5.
5.
bring it up, you would check how to reduce it, which I think is the next slide actually. So that's how you add or subtract fractions. If they have like denominators right off the bat, you don't have to do all those steps, you just do it like normal. But they're going to see more of the unlike denominators than like denominators. Questions?
Cool.
That's why we have the video to refer back to. Oh, I'll make sure okay. So reducing is an old thing. All right. So the next thing we are going to talk about is the comparing of fractions. For comparing fractions, there are two methods. One is going to be find, create equivalent fractions, same way we just did. It would be 4/5 times something equals something over something. The easier and most straightforward way is the butterfly method. The butterfly method is what I was doing with the pictures. You should have seen the kid's face when, like the day before the math benchmark, I told them, you remember all those times I've been making you make equivalent fractions by hand? There's a much simpler and faster way. And then they just looked at me, and it helped them a lot on the benchmark. So they know how to do it now. I didn't want to tell them during the fractions unit because I want to make sure they have a solid foundation. But now they know how to do it, so it's okay to use this when you're practicing at home. So when it's comparing, they're going to have three choices. They're going to have greater than, less than, or equal to. So when it says compare, it might have it like that, or more than likely we'll have it set up like this. Important to don't confuse that with the subtraction sign. So what they have to do is the cross multiply method, or the butterfly method. So they circle from bottom to top. 5 times 6 is 30. 8 times 4 is 32. I don't know where I was going with that. And then I'd say that the Pac-Man, the monster, the alligator, any number of things that they want to say it is. Once you get the bigger number, so it goes like that. So that means that that is the bigger fraction. What that basically does mathematically is it forces them into common denominators by multiplying by each other's denominators, but really it just makes life easier. So it's called, but the thing to make sure is you always have to go from bottom to top and bottom to top rather than top to bottom, because if you go top to bottom, it's going to reverse the whole thing and it's going to give you the wrong thing. So it's important to remember to go bottom to top. Yes, bottom to top. And now it's time for you to practice.
No.
Of course. All right. So we would set this up, 1/3 comparing line, 2/8. So what do?
Plus
Yes.
times 8 is 1.
8 times 1 is,
Oh, there you go, bottom. I
8.
just wrote it.
3 times 2 is,
6.
which number is bigger?
8.
8, so Pac-Man or alligator monster, whatever. Let's see the 8. It's much simpler to do it that way than to make equivalent fractions. Personal preference. Some students like to make the equivalent fractions for whatever reason, but this is a much simpler, faster way. Questions on this? Next way is going to be ordering fractions. And for ordering fractions, there are a couple of ways to do it. Again, you can make equivalent fractions. The big drawback to that is you would have to find the LCM of 3 different numbers. And on release tests, I've seen that it's like 2, 5, and 9. Which 2, 5, and 9, the common least common multiple is 90. So they would have to extend it out to 90, then they would have to do all sorts of multiplication. So an even easier way is to use a calculator. So for your calculator, this is where it comes to very important that they know how to do fraction as a division statement. Because they take 1/2 and they do 1, probably would help turn the pointer part on. 1 divided by 2 equals 0.5. Then they just take 0.5. They do the same thing with 3/5. 3 divided by 5 equals 0.6. They do the same thing for 2/6. 2 divided by 6 equals 0.3333. I just normally have them just do two decimal places and round up. Then from there, now they're all kind of in like terms and they can order them. Another thing that's really important when they are ordering them is to put it in least to greatest or greatest to least. And another thing that's important is when you're the teacher to make sure you write least to greatest or greatest to least on the slide that you're currently presenting. So we will say that I wanted this in least to greatest. So they just have to look at the numbers then. So 0.33 is the smallest, obviously. So it goes 2, 6. Then it would be 1/2, and then 3/5. Some students, as they're working on IXL independently in the morning, in the mornings I normally let them choose what they want to work on in IXL. Some students have chosen ordering, so some of them have been exposed to the way to do it with calculator. Not all of them have yet at this point. They will within the next week or so. But this is, show them that it's okay. If they try to tell you that, no, Mr. B doesn't want me to use a calculator, this is something that they will be allowed to use the calculator for on the S1. Pretty straightforward. Next slide. If you have a cell phone that has a calculator on it, cool. I have calculators over there if you want to get up and get one. If you want to grab one over there. So for 2, 6, how would I plug that into a calculator? 2, of course it is wrong. 2 divided by 6 equals, yeah, it's going to give you, I could use that almost. 0.33. For 1/4, how would I plug that into a calculator?
1 divided by 4 equals
0.25. And 2/5, how would I do that? 2 divided by 5. And that gives me 0.4. And let's say that I had written that I wanted that in greatest to least this time, because I very clearly had made that. What order would the fractions go in now? What will come first?
2, 6.
Much simpler, much quicker than doing it with least common multiple, and they will be permitted to use a calculator at that part of the SQL. Is your question?
I remember that 1/4 is like quarters, like to make it into a dollar.
Yeah, so that's another thing that I forget if we talk about this or in another slide. As long as that's going to be one of the conversions that they need to know, so that can even save them even more time. 2/5 is another one that they should know off the top of their head. 2, 6 is one that they probably use a calculator for. That's not a common fraction that they're going to come upon. Using calculators is going to make this significantly easier. All right, the next one is reducing fractions, also known as simplifying fractions. For reducing, this is where you use greatest common factor, the birthday cake. So let's see how well your short-term memory is. What's the next numbers?
2, 3, 5, 7, 11, and 13.
And 13. So now we build our birthday cake. 27, 36. I think we actually already did that, to be perfectly honest. Okay, so I'll do it again because it's not hard to go back. What can I pull out of 20? Oh, this one. 3. So that will give me 3 times 3 times 3. Over here, you pull out a 3 and a 12, a 3 and a 4.
2,
3 times 4 gives you 6. I pulled out in a different order this time, just to show you that you can do it in a different order. 3 times 3 times 12. It doesn't matter what numbers you pull out, it's personal preference. I normally try to pull the largest number out possible, then I have less birthday cake sets. So 3, 3, 3, 3, dead, dead, dead. Which would give me GCF being 9. From there, you take the original fraction that is given to you, 27, 36, and when you're reducing, you're making things smaller. So multiplication is making things bigger. The opposite of multiplication is division, so you're making it smaller. So you divide, and you got the GCF as 9. So whatever you do to the bottom,
now do the top.
so 27 divided by 9 is
3,
36 divided by 9 is
4.
4, which would give you 3/4 is reduced. I would be inclined to say on the SOL, it's not going to give them a question that's going to say simply reduce 27, 36. The way it will appear on the SOL, most likely, to use some probability words, is that it will give them an addition and subtraction word problem, and then it will say the answer must be in simplest terms or reduced to lowest terms. So they will have to do reducing, but they might not see it as cut and dry as reduce this fraction. We'll do one together. Yeah. All right. So we have to do our birthday cake, which means we need our magic numbers, and what are they?
2, 3, 5, 7, 11, and 13.
You walk out of here with nothing else but the magic numbers. You've made progress.
Yes.
So we make birthday cakes. What can I pull out of 25? 5, which would give me
5.
5 magic. So we got Hale's nice and small cake. That's like maybe a little weekend celebration.
Yeah.
What can I pull out of 60?
5.
5. You can multiple 3 or 2 out. 5 is going to be easiest because that's the biggest number. How many 5s can I pull out of 60?
12.
12. What can I pull out of 12?
3.
3. Which could be 4. You could have pulled 2 out. And then 2. And 2. Didn't leave myself enough room there. 2 times 2 times 3 times 5. So then I didn't have to write all that. So then what do they have in common?
What do you have about the 4th one?
That's a comma and a 2. I didn't leave myself enough room. It's a 2. There's. I wasn't prepared. It's just clearly a 2. I do that to the kids all the time. They're like, Mr. B, you made a mistake. I'm like, what are you talking about? Good thing I don't record all my lessons. All right, so what do they have in common? 5. Everything else is done. So then they take this 25 over 60.
Divide by 5.
Divide by 5, whatever you do at the top.
Divide to the bottom.
5 over 12. And then 5/12 is what that reduces down to. So that's pretty much all the things about fractions. So that's reducing fractions. We good? For the most part, revisit the video.
You're gonna tell us these numbers when we come back to that with the kids, right?
They'll know, and they're little
Well,
kids.
that's not fair.
Sounds like an excuse.
I just want to know if for the challenge with the kids, do we have to show our work or do we just come up with the answer?
Right, you gotta
Why
show
don't we just come up
What do we always do in this
Oh.
class? We always have to show them. All right. So next part is going to be decimal. Oh, while I'm thinking of it, I told a couple kids that if they were watching at home, I would count it as them being here. So I told them I would say a code word in the middle of the presentation sometime. So for those of you watching at home, the code word is Stonewall Jackson. The code word is Stonewall Jackson. Your kids don't need that because you're here, but if they want to eat lunch, and I told them they had to watch the broadcast and then tell me the code word. So I'll be interested. Don't tell your kids what the code word is because then they'll tell their friends. So Stonewall Jackson, again, which is for next week. Just a little brief. Back on track. Decimals, again, they'll have to identify words, numbers, number lines, pictures, add, subtract, compare, and order, and fraction equivalents. Words, that's pretty easy. Numbers, as long as you remember and means decimal versus just saying and. Number line is, it's going to be out of either, it's going to have 10 different things, kind of like the fraction number line. Pictures, it's going to be important to know if it's the whole long thing or those small little things. Really, for those first couple concepts, it's going to be very helpful to revisit the decimal homeschool connection like that we did sometime last month. Adding and subtracting decimals is what we'll go over tonight. Comparing and ordering, I think we'll go over that tonight as well. And fraction equivalent, we will also go over tonight. All right. So first thing is going to be subtracting fraction, or those are actually decimals. So you say fraction. So when it says difference, that means subtract. So they have to line up the decimal. There's a really cool YouTube video out there filmed by a very extraordinary person called Line Up the Decimal. I'd recommend checking it out. So 6.3, 2.789. Now they see that they have gaps. So what they can do to fill in those gaps is just put zeros in. So I tell them, you can put as many zeros as you want after the last digit, or really even before a whole number, as many zeros, and it doesn't change the value. It's just when you throw other digits in there. So then they would subtract. Now, big mistake here they're going to make is subtracting across the zeros. And so they can't take 9 away from 0. Sometimes they will say, well, and they'll just reverse it. And so I'll hold up my fist like this, and I'll say, take away 9 fingers. And they'll look at me like I'm crazy, because I am a little bit. But they look at me, and they said I can't do that. So then I say, why could you do it there? So then to subtract across zeros, they go over and they borrow, exchange, whatever the new word for it is. They get from there, they turn here, and then that comes to 10. So you can take 9 away from 10, which would give you 1. 8 from 9 is 1. They can't take 7 from 2, so they would have to go borrow, make that one 12. 12 minus 7 is 5. Simply drop the decimal point. And 5 minus 2 is 3. But they're not quite done yet. Why are they not quite done yet with this problem?
They have to
They
verify.
have to check.
They have to check it. So what they do to check it is they just take the bottom two numbers and they do the reverse operation. So the reverse operation of subtraction is addition, just like the reverse of multiplication is division. So they just take the bottom two numbers, which are 3.511. Didn't leave my soul for it. That's why I went right from this side there. And so, all right, 9 plus 1 is 0, carry, 0, carry, 3, carry, 6. So 6.3, 6.3, 2.7, 2.7, 3.5, 3.5. As long as they match all of them, they're good to go. If something doesn't match, they're not good to go. They need to go back and find where they went wrong. We're going to do one together. This one's for you. It says sum of 1.5 and 6.259. So what does sum mean?
Add.
Oh, looks like a comma. Not the right number.
7.759.
Did you check it with the reverse operation?
No, of course not.
Well, then you're not done yet.
But what if we're confident on our addition?
It doesn't matter.
Sounds like you're talking to a brain.
It sounds like I'm talking to 22. So 0 plus 9 is
9.
9. 0 plus 5 is
5.
5 plus 7
That's
is.
supposed to be it. You're set.
It's 6.259.
That's why it's a 2 there. It's clearly a 2. 5.2, 5 plus 2, and then 7. So you got 7.759. So clearly I have 2 there the whole
I
time.
got it wrong.
Stonewall Jackson. Hope they weren't watching on network. And then you subtract it. 6.259. Lovely. Everybody makes a mistake out there. All right. That's how you do that. And you also make sure that they check. Very straightforward. As long as they write the right numbers, they should be fine.
Remind them of that.
Remind them that writing the right numbers is important. Okay, so I don't. Okay. For the sake of time, I chose to omit how to compare and order fractions because you can always revisit the decimal one. All they do there is simply line up the place values of the decimal points and circle numbers. So I did talk about the fraction and decimal equivalent. 2 ways to do this. They can simply memorize the 4 common ones, or they can also use a calculator. So for 1/4, I tell them think of quarters, because quarters are 25 cents. So we have what the fraction here is 3/4, and over here 3/4 is 75 cents. Pretty straightforward. I'll tell you quarters and halves, they don't mix up too much because it relates to money, which is important to a lot of people, including myself. So this one over here is 1/2, and that equals 0.5, because that's $0.50. The 5ths and the 10ths are where they're going to mix up a little bit more. And I'll show you how to do that on a calculator. So first thing, this one is 3/10. What I tell them for 3/10, what they can do, 3/10 is just a decimal, 0.3. So what I tell them that if they can't remember that in their head, just if it's a 10 on the bottom and you need it in decimals, just take the numerator down and just put it there, and it's 3/10. For the 5ths, that is 1/5, and I tell them that 1/5 is, you can turn that into a tenth real easy by multiplying the top and the bottom by 2. So I tell them that they can either, work it out 1/5 times something equals something over 10, work that all out, and get 5/10, 2/10, or they can simply, when they see a 5 on the bottom, double the numerator and drag it over. So 0.2. The other way that they can do this is use their calculator to verify it. As long as they can figure out what fraction it is from the picture, so that one was 3/4. So what they would have to do there is 3 divided by 4 equals, and that's 0.75. Same thing, we'll do the 1/5 before we move on. 1/5 divided by 5 0.2. So they can verify with that. They can memorize it. Either way, they have a multitude of ways to make sure that they get their correct answer. Questions about that? All right, the next thing that we're going to talk about is multiplication, which we're going to talk about both lattice box and traditional, which is kind of what multiplication is kind of what sparked all these homeschool connection nights, because I had heard last year and this year that parents are generally strong with traditional, didn't quite know what lattice box was, versus which is the reverse of students. Students are pretty much strong with lattice box, not as strong with traditional, and they will also have to do multiplication in word problems. While I'm here, so I don't have to keep clicking back, we will also model long division, which there's only one method for that. There are more than one method, but I only taught them one method. And they're going to check that with multiplication. All right. So for multiplication, first of all, they need to know product means multiplication. So it might say, what is the product of? It might have something, a word problem saying like, Jimmy had 7 jars. Each jar had 18 things in it. How many things did he have total? Probably be a little bit more restricted than saying things, but you get the idea. One big mistake that I've noticed is they might divide when they're supposed to multiply, or multiply when they're supposed to divide. They might not make a mistake with actual division or multiplication, but they'll do things. They'll mix up with one thing. Big clue and giveaway is going to be if it has two numbers that are greater than 1 digit, it's most likely going to be multiplication because we don't do division with 2 digits. So that's a little hint you can give them. So for product of 238 and 45, I'm going to show you both ways, traditional and lattice. So 238 times 45 is, I tell them to circle the numbers, just keep track of what they've done. So 5 and 8 is 40, carry the plus 4, circle. 5 and 3 is 15, plus 4 is 19, carry that. 5 times 2 is 10, plus 1 is 11. And then I tell them to cross those off because the 5 is circled with everything else, so they're done with it. I tell them when they move over to the next number, they have to put in a 0. That's even part of it. Yeah, we're going to ask them to model that for you sometime. So they do 4 times 8 is 32. The 2 goes down, plus 3 up there. I don't even know what that's supposed to be at that point. 4 times 3 is 12, plus 3 is 15, plus 1. 4 times 2 is 8, plus 1 is 9. Simply add those up. 0, carry, 7. So 10,710. That's traditional. That's probably what you guys are most comfortable with. That's kind of what I grew up with. That's kind of been the standard.
Do we have during the test, do we have to do all these circles everywhere?
Do they? Or are you talking for the homeschool connect?
Yeah.
Yeah, you have to show all your work.
With the circle?
Yeah. You have to do it as if you were in Mr. Beast's 4th grade class.
Why
He would make you say,
we shouldn't even show up.
Can we cheat off our kids?
No, because then I'll move you down. You're not even going to be sitting near your kids. Parents are going to be over here, kids are going to be like over there. It's going to be fun. Now, the other way for, I'm going to really skew it so the kids win. I'm going to tell you that right now. What?
We're going to get blown out of the water.
What?
We're going to get blown out of the water.
Yeah.
No, we're not.
Yes, we are.
Do we just work as a team, like parents against the kids? Is it
How much that? We'll see how well behave you guys all are. Maybe the kids can work together. All right, so lattice box. So lattice box, the hardest part half the time is just simply drawing the box. So they know 238 is going to have to go on the top, so they're going to need 3 spaces. 45 is going to go on the side, so they're going to have 2 spaces on the side. They fill in 238, multiplication symbol, 45, and then they put in their diagonals. The best way to put in your diagonals, I found, is do each box individually rather than trying to do the whole rectangle. Because some students will start their diagonal here, try to get it out to here, but that doesn't diagonal that way. So I just tell them corner, corner, extend, corner, 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 extend, corner, 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 extend, and corner, corner, extend. Then that helps them put in. So then they pick a number, and I tell them go up and over. So 8 times 4 is 32. 8 times 5 is 40. 3 times 4 is 12. 3 times 5 is 15. 2 times 4 is 8. They put the 8 down there and the 0 because there's 8 ones. If they reverse it, that would be 80 and not 8, which will throw off their answer by significant. especially over there. Up here would be 2 times 5, that would be 10. Then the last step is to simply add up the diagonals. So 0, 2 plus 4 is 6, plus 10, 5 more would give you 11. Carry the 1 up there. 1 plus 3 is 4, plus 2 is 6, plus 7. That would be 10.
Can you do that again?
Sorry, I made a mistake in there. All right. So I just added up the diagonals. I'll go one side. So the 0 is what was by itself. So I just drag that down. So then these are kind of sandwiched in between the two here. So it's 2 plus 4, which gives me 6, plus 2 more would be 11. So the 1 goes down there because you can only have a single digit in between each sandwich. I don't know what you want to call it. So you got to carry that one up there. So 1 plus 3 is 4, plus 2 is 6, plus 1 is 7. And there's a 0 there. So that brings down. Then it's 1 plus 8 is 9, plus 1 is 10. So the 0 goes down there, plus 1 goes up there. And then there's 1 plus a 0, so that brings up there. And I believe my answer last time was 10,710. So that's the way I like to have them do both traditional and lattice. That's a really quick and easy way to check themselves. If we would have done double-digit division, it would be a little bit easier. We're going to practice one. For the sake of time, we're just going to practice the lattice box way because traditionally you've probably been doing for, I don't know how I want to phrase this, longer than lattice. So first thing we need to do is set up our lattice box. So we are going to make a rectangle. How many vertical lines am I going to need?
2.
2. Because I'm going to need 3 spaces. How many horizontal lines am I going to need?
1.
1. What's going to go on top?
148.
5, 55.
So it's easiest to put in diagonals one at a time. So you go corner to corner and extend it. Corner to corner, corner to corner, extend it. Corner to corner, corner to corner, extend it. And corner to corner, extend it. From here, all you need to do is just pick box. Doesn't matter what box, you can go in any order. I'm going to pick the upper right. So you go up to 8 and over to the 6, which would give you 48. So you put a 4 and an 8. You drop down, and now you go up to the 8 and over to the 5, which would give you 40. Go over up to the 4, over to the 6, gives you 24. Drop down, go up to the 4, over to the 5, gives you. Go over, go up to the 5, up to the 1, over to the 6, and you make sure you put it in as a 0, 6. Up to the 1, over to the 5.
5.
With me so far?
Yep.
All right. This is the part where it gets a little confusing adding the diagonals because you have like so many different lines. So the 0 is by itself because it's got nothing in between it. It's got nothing in its row. So you just bring the 0 down. Then between this sandwich is an 8 and a 4, which is 12. So the 2 comes down here, and you bring the 1 up there. So 1 plus 4 is 5, plus 4 more is 9, plus 2 more is 11, plus 5 more is 16. So the 6 goes down, and you pop a 1 into that box. 1 plus 2 is, plus 6 more, 9. Which will give your answer is 9,620. So lattice box, this is by and large easier for most of the students because if they forget to move when they move over to the when they moved over to the 6, if they're doing traditional, it's going to throw off their whole answer by thousands. So this makes it very visual for them to make sure that they have multiplied every single number. They don't have to worry about the whole moving over kind of thing. As long as they know the basic facts, they can do this. So lattice box, I really advise them to use lattice box. I do advise them to also check it with the traditional. For long division, and I'm running over time, so I'll just model this. You can follow along with me on this one if you'd like, but I want to make sure I hit elapsed time and the SOL reviews before we go. So for 478 divided by 3, the bigger number needs to go inside the house. I'm going to tell you right now, I haven't left myself enough room. There we go. 478 and 3 goes in the inside. So they basically follow a very set algorithm, a very set pattern. One day I actually wrote the steps on my fingers, and I divide, multiply, subtract, bring down, repeat. And then I said when I have my fist, then I open it back up, and that's repeat. I had it on my hand, I found out really quickly that black Sharpie washes off pretty fast. Red Sharpie doesn't wash off as fast. I had red Sharpie on my hand for like 3 days. But I'll even today when we're working on long division, I'll say what's on the thumb. So I'll tell them. Some students went home and drew it on their hands too. I didn't tell them to do that. I told them specifically not to do that. But some students walked in the next day and said, "Mr. B, look!" And I was like, "Oh God, did you show your hands?" So some of the kids did do that. So that's a helpful way. Just, they can't walk into the SOL with that one. Just make sure they know that. So the first step is divide. So for divide, I tell them to think, how many times can I fit 3 into 4? How many times can you fit? 1. So 1 would go up there. And the second step is to multiply. So 1 times 3 is?
3.
The next step is to subtract. So they subtract. 4 minus 3 is?
1.
Ring finger is bring down. I even tell them ring and bring, they rhyme. So that's a good way to remember that. And then they repeat. So they do it all again. So how many times does divide? How many times does 3 go into 17?
5.
5 goes up there. They multiply. 3 times 5 is?
15.
Subtract.
2. Bring down.
Yeah, right.
Repeat.
That was hard to do.
You weren't done putting the egg on there.
Yeah. My mind is faster than that. Repeat. Divide is how many times can 3 go into 28?
9. 27.
Which would give you 27 with multiply.
Subtract.
There's nothing left to bring down. So then at that point, when there's nothing left to bring down, the R becomes remainder. And so the R, that's all that's left, R remainder 1. To check this, and this is a common mistake, they know they have to check it at the end, but they're not quite always sure what numbers they need to use to check it. Sometimes they like to use the 2 numbers that were given, which then gives them an astronomical number half the time. So I tell them, the thing in the house is already okay. Just leave it in the house. You want to check the thing that's trying to break in from the bottom and the thing that's trying to break in from the side. So they have to do 159 times 3. They can do traditional lattice, whatever they want to do it. And I'll tell you when you multiply that, that becomes 477, which doesn't match up there. So what they have to realize is when you have the remainder, you also have to add that in. I was able to figure that out. They add it up, 478. That matches that. And now you're correct. Really no excuse to ever get a long division problem wrong because the checking is built right in. If they don't match, first thing they should check is if they remember to add the remainder. Second thing they should check is if they made a multiplication mistake. Third thing they should do is restart the whole problem. But if they check the remainder first, check the multiplication, then check the long division, that'll save them some time rather than restarting the whole long division.
They could have wrote the wrong number.
That doesn't sound like All right. The last skill we'll talk about, and I apologize, I was doing good for a while getting done on time, but apparently I stopped that. We're going to talk about elapsed time, which you can all kind of breathe easy when we talk about it. You see, elapsed time is not going to be a huge part of the SOL. It's going to be one small snippet of it. Still important skill to know for life thing. They will only need to do it with the timeline method, which is the start time and the end time method. When we did in class, we did start time and an elapsed time, and they had to find the end time, they had elapsed time, they had to. They don't need to know those extra other parts. They know to need to know those for life, but for SOL, they only need start time and end time, which is going to be the timeline method, which is what they were better with. So I'm way off something. All right, so timeline method, and again, I'd advise you to do this with me just for the sake of time. So for timeline method, they simply first need their timeline, which looks like a big capital I if it fell down. So the start time is 8:35 a.m. and the end time is 1:15 p.m. Going to be important to include the a.m. and p.m., especially if they cross over noon. So what I have them do next is I have them put in the next whole hour after the 8:35. So the next whole hour after 8:35 would be 9 o'clock a.m. The next whole hour would be 10 a.m. Oh, 6. Then 11 a.m. Then 12 p.m. because that's noon at that point. Then 1 p.m. and they don't have another whole hour after that because they would jump to the 1:15. Now I tell them to come back and do their minute jump. So from 8:35 to 9 o'clock If they can't figure that out, what they can do is subtract that from 60, because 60 is 1 whole hour. So we're doing 60 minus 35 will be 25. And so that first jump counts as 25 minutes. Then they have to do all their hour jumps. So I have them count it out in their head, out loud or in their head as they're jumping, rather than stopping and writing after each one. So that would be 1, 2, 3, 4. So they have 4-hour jumps before they do the last one. 4 hours, and then they have one last final jump. 1 to 115 is 15 minutes. It's important to make sure that they know when they're going from last whole hour to the minutes, it's just a minute. Sometimes they'll try to reverse it and say it's 45 minutes. So then they add it up. So 4 hours and 25 minutes is 4 hours, 25 minutes. Plus another 15 minutes would give them 4 hours and 40 minutes. And they could check that by, starting with 8:35 and counting up, or starting at 1:15 and count that. But if they've done this and they can kind of look at it, they should be able to figure it out. I do have another example prepared if you guys want me to run through another. I know I've ran over time. I'll leave it. If you want me to go through one more example, I will. If not, I can move on.
We can
Go
go through it.
I'm
Yeah.
good with that.
So, timeline method again. Start time, end time. It's going to have capital I that dropped on its side. Start time is 10:30 a.m. End time is 3:45 p.m. So what's the next whole hour after 10:30? 11 a.m. And then
12. 1,
2,
3.
we don't have to go to 4 because it's so now we're doing our jumps. From 10:30 to 11 is
30.
count for me.
1, 2,
2, 3, 4, 45.
So now they added up 4 hours plus 30 minutes is 4 hours, 30 minutes plus 45 minutes is going to give them 4 hours and 75 minutes, which is really possible. You can't have more than 60 minutes. So what they would have to do here is subtract 60 because they know that's an hour. This is what's going to screw them up most, is the subtracting 60. Since the rest of our number system is based on base 10, subtracting tens or hundreds is how you do that. This is subtracting 60, which is kind of what makes elapsed time as a hard thing. So when they subtract the 60, they are getting it to the hour. So now they have 5 hours and 15 minutes. They're, generally speaking, pretty good at recognizing you can't have more than 60 minutes because that's kind of been drilled in their head since like kindergarten. They just don't always remember to switch that 60 minutes over to the hour. But timeline, you can rest easy that it's not the count back method or the count up method, which kind of had some of the kids and probably you guys pulling your hair out for a couple weeks there. So that is elapsed time, I think. That's the class. Very cool. All right, I can finish it. Okay, great. All right, so I'm going to go over really quickly. This is what I printed out for you guys to take home and really review. The kind of the inside scoop on the reading SOL and the math SOL. We will go over the inside scoop of the Virginia Studies SOL next week. So reading SOL, first and foremost, is Wednesday, May 20th, a week from, 2 weeks from tomorrow. The best way to prepare them is going to be reading every night and asking them questions every single night when you're reading. Like I said to the kids, like I said to you guys, you read 20 minutes a night. By the end of the year, they've read 2,000 words, or 2 million words. If they haven't been reading 20 minutes a night, it's better to start now than to wait. MrNussbaum.com is a really good website that has a lot of reading online comprehension stuff. It's going to be very structured like the SOL.
I tried to get on the website, but I think it's pay. You have to pay for it.
You can pay for it, but you don't have to. They have all sorts of free stuff. You just kind of got to, if you go to the website, then you click on 4th grade. It's like a banner along the top.
Yeah, so I tried.
And then you click on language arts, and then you click on online reading comprehension exercises. And there's like 37 of them or something like that for just 4th grade. Then they have above and they also have below. There are also release tests on the Virginia Department of Education and release test items. The only thing I ask is please do not do the most recent one with them at home. We're doing that in class as an activity. If you did it already or if you want to, it's fine. But we are doing that as test practice. So, but there are like I wouldn't say hundreds. There's a whole bunch of them on there. Just the most recent one we're going to be doing Tuesday or Wednesday of next week. Just to give me an indication of how it will play out next week. IXL language arts will be kind of helpful, but not very helpful. The ones that will be very helpful are going to be MM, NN, QQ, SS, UU, VV, and WW. Those are all word skills type thing, prefixes, suffixes, multiple meaning words, context clues, synonyms, antonyms. Those are going to be helpful. The ones that I could see being helpful are going to be XX, YY, and TT. Those XX and YY are going to deal with Greek and Latin roots, which help them develop vocabulary and break words down. TT is going to be about, I don't remember for the life of me what it's about, but I at some point thought it was helpful. I would not spend a whole lot of time on IXL preparing them for the reading SOL. I would spend the bulk of my time reading with them, asking them good, valid questions, ones that are going to make them think beyond the text, not ones that they're going to be able to find exactly in the words, and a lot of time on the Virginia Department of Education and the MrDustBomb.com. IXL language arts will be helpful for a couple skills, but the language arts ones are going to help with this vocabulary section. So this is how this is called the blueprint of the SOL, and this is how it actually works out for me when I'm looking at it. There are going to be 47 questions total for the students. There are going to be 40 questions that I consider real questions, and the Virginia Department of Education counts them as real questions, and there are going to be 7 questions that are called field test questions, which means that they're not going to count for or against the students. I don't know which 7 are the field test questions. There is no indication that says like this question is a field test question. So they're going to have 47 questions total. 40 of them will count, 7 won't. I don't know which ones. There's no official amount of passages given, but I would expect more than a reading quiz. No, at this point in the year, reading quizzes are about 3 passages. Last year they had, I'm not really supposed to be looking at the screen when they're taking it, but as I was glancing around, they had I saw 7 to 9 different passages. It's not all little novels they're reading. Some of them are like a poem that's a couple lines long. Some are directions on how to do things. They're going to have a variety of different things that they're going to have to read. I think the longest one, if you go on the Virginia Department of Education, the release tests are going to give you an indication about how long these passages are. A couple paragraphs, it's probably not going to be, they have like screens, so it's probably about 3 screens, which there's probably about 2-3 paragraphs on each screen. So more stories overall than a reading quiz, but about comparable amount of words, if that kind of makes sense. It's going to be broken down into 3 sections. So it's not going to nice and neat be like these 7 questions are about this, these 17 questions, and these 6. But overall, this is where the 40 questions are going to come from. 7 of the questions are going to be about vocabulary skills. So that's going to be either context clues, prefix, suffix, antonym, synonym, or word reference materials, which are dictionary, glossary, and thesaurus. Both of them are going to come from these first ones, prefix, suffix, antonym. This is where the IXL language arts is going to be helpful just for this section, which you see overall is a smaller section, but still an important section. The second section is going to be comprehension of fictional texts. Those are going to be made up stories. They're going to have 17 different questions about that. So that covers stuff about author's purpose, which we've talked about, main idea details, which we've talked about, problem solution, which kind of goes along with all those other skills, sensory words, which kind of goes along with author's purpose, conclusions and inferences, which we've talked about, I think 3 times now, predictions, which we've talked about, and cause and effect, which we've talked about. So pretty much everything that's going to be in there, we've covered in Homeschool Connection Notes. Comprehension of nonfiction is going to be 16 questions. It's going to be text structure, which text structure basically just means like headings, captions. Like sometimes when you're reading a textbook, it defines the little words like a mini glossary within the thing. That's kind of what text structure is. Pictures, that kind of stuff. Formulate questions, like that might be which question could be answered in this passage, or what question would be help you find the main idea. Author's purpose, we talked about main idea, problem solution, fact opinion. Fact opinion is going to be huge to know that just because you can prove it, you can see it in the passage doesn't make it a fact, doesn't make it an opinion. You need to think if it can be proved by looking at another source or something like that. Conclusions, inferences, or cause and effect. That's kind of how the Virginia Department of Education has the blueprint print posted online, but it's like a 7-page document, so I just want to condense it down to 1 slide for you guys. That makes it a little bit easier for you to kind of fathom what they're doing. Math SOL Inside Scoop. It's going to be taken over 2 days. First day is going to be Wednesday, May 27th. They will not be allowed to use a calculator at all on that day. On day 2, which is the following day, they will be allowed to use a calculator. IXL is going to help tremendously for this, prepare them. It will allow you to really target their weak spots and you know, really go from there. It's going to talk them through examples. It's going to be the little paper I sent home a little bit a week or two ago, maybe 3 weeks ago, has exact listings of which IXLs they should be practicing. That paper is also on my website under forms. It's called How to Prepare for SOLs if your child has lost it or it never even made it home. It is on my website for you to download yourself. Mathaids.com has free printable worksheets, completely free. They have ads on the site, but you just click out of those. Completely free if you know you're on a trip or something and they won't have Wi-Fi. Print them some worksheets to work on. We don't do a whole lot of worksheets, or if you're going on a vacation or something, print a lot of these worksheets. We don't do a whole lot of worksheets in class, so this is going to be a good way for them to practice at home. And a really good resource is going to be all these homeschool connection and YouTube videos, because these are basically modeled examples that I've been talking through. Tonight is going to be probably one of the best ones to watch, not to like brag about myself or anything, but it's going to be very helpful to go back and look through those. They can pause it and rewind it as they need, but those are going to be very important for them to look through. And they're all narrated by me, except for the one that's, I forgot to plug the microphone in for that one.
So you said to go on forums and what else?
If you go to forums, and then it's just one of the files at the top. It's called How to Prepare for SOLs. And it's got a breakdown of all the IXLs that are going to be helpful. Because IXL has more than we need, and it's lacking in some areas. But generally, IXL is pretty good. I'm glad that we wrote the print for it. MathX SOL, how the blueprint. There are going to be 60 total questions. 50 of them are going to be real questions. 10 of them are going to be field test questions. Again, don't know which one are the field test questions. Computation and estimation is one of the report and care of cores. There are going to be 13 questions, and those are ones that they are not allowed to use a calculator for. They have to do those completely by hand. That's going to be day one. So on day one, the silver lining is they only have to do 13 problems on day one, which is less than like a math unit test after that. So that will include adding, subtracting with whole numbers, decimals, and fractions, multiplying with whole numbers, or multiplying, dividing with whole numbers, LCM, GCF, simplifying fractions, word problems, and estimation. So any skill that I kind of showed you how you have to do it by hand is what they're going to do on day one. Day two, we'll have the number sense, measurement, and the probability. 12 questions for number sense. That's all about place value with whole numbers and decimals, rounding, comparing, and ordering. I say that for number sense, calculators is allowed, but they probably won't need it. For ordering, it would probably be helpful, especially for the fractions. Equivalent fractions and decimals, again, might not be needed if they can remember those conversions off the top of their head, but they always have a calculator to fall back on. For measurement and geometry, 13 questions. That's going to be mass, weight, length, capacity, which hopefully they'll do pretty good with those three because that's what we're still finishing up. Elapsed time and geometry. Calculator may be needed. I would definitely recommend using calculator on these last couple ones because they might remember the conversions, but knowing like there's 16 pounds and there's 16 ounces in a pound, rather than making the silly mistake of multiplying, just use your calculator and make sure they're looking more that they know the conversions more than they know how to multiply that one. Last section is probability, patterns, graphs, and equality. Equality is just a fancy way to make sure that both sides of the equal sign are equal. 12 questions about that. Probability, that's going to be the words, the likely, unlikely, equally likely, all that stuff. Fraction, the number line. Patterns, the big thing about patterns, it's not going to be as simple as what would be the next number of the sequence. It's most likely going to say, it's most likely going to give them 4 numbers and then say what's the 6th number in the sequence. So they have to figure out the pattern and then extend it to. So very important to know that. Interpret and create graphs. They're going to see graphs. They're going to have to make graphs. They're going to have to make graphs from directions that say like 4 of this, or they're going to have some words that says like John has 6 of these and Billy has half of the amount John has. So they have to really understand that. Equality, that just makes like if it was 5 plus 2 and it says equals 6 plus blank, they would have to figure out what would go in blank. Associative property, we didn't formally go over that in any homeschool connection night, but what associative property means is associative property, all that is if it's 6 times 2 times 3, or there's going to be addition symbols, it doesn't really matter. And then it's just equality across. The only thing with associative property, the parentheses might start here, parentheses might start there. That's all they need to know about the associative property. That builds on what they need for next year for 5th grade. Associative property, the symbols stay the same, the numbers stay in the same order, the parentheses are the only thing that moves. It's really simple. They just need to recognize which is an example of associated property and which one is not an example of associated property. That's the reason I didn't spend the whole, it's pretty straightforward. All right, which brings me to a new record in going over on time. Thank you for joining me tonight for the last hour and a half when I quoted you an hour. Make sure that you are using these strategies with tribe. Your sport's really gonna make this difference, especially in this last like 2.5, 3 weeks of crunch time. It's gonna be, I know it seems like a short time frame, but this can really make or break things. Go on IXL as often as possible. Really take the time and revisit the old homeschool connection nights with your student on the YouTube. They're all organized on playlists for you. They're posted on my website. They're posted more ways than you possibly ever need them. Make sure you complete the feedback slip, which is going to be on the next slide when we're done. And I'll see you next week for the Virginia Studies Homeschool Connection Night, which that one's going to be very, very fast-paced because I have to fit 408 years of stuff into 90 minutes, and I can't even do some stuff in time and life. And then the students versus parents one, which will be interesting, is going to be 2 weeks from today. So, do we have any questions, or do you just want to get out?
We let her bring cheat sheets for the kids versus the parents.
Right.
I'll let them bring cheat sheets.
All of
So we
our
can write
grades.
like all these little things that you've given
Well,
us.
I guess I said that I encourage you to look back for the homeschool connection. All right, and again, that code word was Stonewall Jackson for those of you watching at home.